You ever open up a spreadsheet and your eyes just glaze over? Just rows and rows of numbers. It feels like pure noise, right? Well, what if I told you that inside all that chaos, there are these amazing stories just waiting to be told? That's what statistics is all about. It's kind of like a secret language for turning data into incredible narratives. So, how do we get fluent? Let's dive in and find out.
So here's our game plan. We're going to tackle this in 5 parts. First, we'll look at how to make sense of all that data. Then, we'll get into the 2 main ways we can describe what happened and even predict what's next. After that, we'll see how we put those predictions to the test. And finally, we'll wrap up with why these stories are so important. Okay, let's jump right into part 1, making sense of data. Going from just noise to a real narrative. Picture this. Someone drops a massive data file on your desk. Thousands, maybe millions of rows. At first glance, it's just chaos. So the big first step, the whole challenge, is figuring out how to wrangle that chaos into something that actually tells a clear story. And that really brings us to the central question, doesn't it? How do we turn all those raw numbers into a clear story? How do we take something that feels so random and give it structure, give it meaning, maybe even a plot? Well, to do that, you need the right set of tools. And that toolkit, of course, has a name. And that name is statistics. At its heart, that's all statistics really is. It's this amazing toolkit. And it's not just about doing complicated math. It's a whole system for summarizing, organizing, presenting, analyzing, and finally, interpreting all that numerical data so it actually makes sense to us. Okay, and this is where it gets really cool, because statistics gives us 2 totally different ways to tell the story of our data. Think of it like having 2 different kinds of storytellers. Let's get into the first one. So, meet storyteller number 1, the historian. I like this analogy because this approach is all about looking backwards. It takes all the data you've got right in front of you and just tells the facts. It describes exactly what happened, no more, no less. And this is what we call descriptive statistics. The key thing to get here is that descriptive statistics doesn't guess, it doesn't predict, it doesn't go out on a limb. Nope, it just describes what is. It takes a big pile of data, whether that's a small sample or a whole population, and just boils it down to the basics, the main takeaways. So what kind of tools does our historian use? Well, you've got things like frequency distribution, which is just a fancy way of saying we're ordering the scores to see what pops up most often. Then there's graphic presentation. This is the one you know and love. We're talking charts and graphs, things that turn a boring spreadsheet into something you can actually see and understand. And finally, you have measures of central tendency. Think mean, median, and mode. It's all about finding that one number, like an average, that can kind of represent the whole group. Super simple, really powerful, and 100% based on the facts. All right, but what if you want to do more than just describe the past? That brings us to our second storyteller. If descriptive statistics is the historian, meticulously recording what happened, then inferential statistics, well, that's the futurist. This one looks at a small piece of the story and tries to predict the whole epic. Yeah, this is where we make the jump from describing what we know for a fact to making a really smart, educated guess about a much, much bigger group. You take a small sample, right? Let's say you survey 1,000 people, and from that small group, you try to infer or predict what an entire country of millions of people might be thinking or doing. This right here, this is the absolute engine of scientific research. So let's just put them side by side for a second. The historian, our descriptive stats, deals in certainty. It just describes the data it can see. But the futurist, our inferential stats, works with probability. It takes that little piece of data and makes a leap, a prediction, about the whole big picture you can't see. But, predicting the future is hard, right? It's never a sure thing. So the futurist has to deal with a lot of uncertainty. For example, you could have a sampling error. That's when your small group, just by pure random chance, doesn't perfectly reflect the bigger population. Or you could have sampling bias, which is when you didn't pick your sample carefully and you accidentally surveyed the wrong group of people. To deal with all this, statisticians have this cool concept called a sampling distribution. You can think of it like a theoretical map of every possible result you could have gotten from all possible samples. It helps them figure out if their own result is pretty normal or if it's a super rare outlier. Okay, so our futurist has made a bold prediction. Now for the exciting part, the moment of truth. How do we know if that forecast is legit? How do we test whether it's likely to be accurate or if it was just, a complete lucky guess? I mean, this is the million-dollar question in pretty much all of science, right? We've got our hypothesis, this prediction based on our little sample. But is it for real? Well, the funny thing is, to find out, we actually have to try and prove it wrong. And we do that with something called the null hypothesis. Now, this is going to feel a little backwards at first. The null hypothesis is basically the super skeptical position. It says, nope, there's nothing going on here, no effect, no difference, no relationship. It's the default assumption that nothing interesting is happening. Our job as researchers is to find enough evidence to say, sorry, null hypothesis, but we're rejecting you. Something is happening. And there's a really clear, structured way to do this. It's like a 4-step process. First, you state your actual research hypothesis, what you think is true. Second, you state the null hypothesis, that skeptical opposite. Third, you choose the right statistical test for the job. And fourth, you decide ahead of time what your level of significance is going to be. Basically, how much proof you'll need to be convinced. And to help us visualize this, we use the famous normal curve, or the bell curve, as most people call it. Think of this as our map. It helps us see if our results are truly significant or if they could have just happened by random chance. See, most results are going to fall right here, in the big middle part. That's what's normal, what's expected. But if our result lands way out here, in these little tails on the edges, that means it was a really, really rare event. So rare that it's probably not just a coincidence. And we can get even more specific with our tests. If our hypothesis predicts a certain direction, like we think a new drug will specifically lower blood pressure, we use what's called a one-tailed test. We're only looking for a result in one of those tails. But if we just predict there will be a difference, but we're not sure if it'll be higher or lower, then we use a two-tailed test. We're basically looking for a rare event at either end of the curve. Okay, deep breath. We've met the historian who describes the past. We've met the futurist who predicts what's next. And we've seen how we put those predictions to the test. So now for the big finish. And honestly, the most important question. Why does any of this matter? Why do these statistical stories matter in the real world? Well, the answer is pretty much everybody who needs to make a smart decision based on data. I'm talking about nursing researchers who are testing if a new treatment actually works, social scientists trying to understand big trends in society, government analysts figuring out where to spend tax money, business strategists planning their next big product launch. Seriously, anyone. And this really gets to the core of it. There's a great quote that says, inference is a vital element of scientific research, since it will predict a phenomenon based on data leading to theory development. What that really means is that this futurist stuff, making inferences, it's not just a cool trick. It's the engine of science. It's how we go from looking at a few little facts to building big, sweeping theories about how the entire world works. It's literally how we create new knowledge. So, it all comes full circle. We started with the idea that data is just noise, but now we see it's full of stories. You have descriptive statistics, the historian, telling you exactly what happened. You have inferential statistics, the futurist, predicting what might happen next. And together they give us this incredibly powerful way to understand our world. So I'll leave you with this question. If data tells a story, what story are you trying to tell?